Audiovisual Aware Foveated Rendering. In this paper, we propose the Audiovisual Aware Foveated Rendering method, AVFR, to accelerate foveated rendering performance without losing visual fidelity for VR scenes containing auditory content. HVS's perception varies under different audio content in VR. To quantify the effects of audio content in VR, we construct a 360-degree panoramic video dataset with auditory content, which includes two types of scenes, forest stream and urban street, with 10 entries for each scene type. We conduct the pilot user study 1 to compare the impact of having versus not having audio content on visual perception in VR. Here are the clips in Pilot User Study 1, which shows a participant viewing an forest stream scene without auditory content. And with auditory content. Experimental results in Pilot User Study 1 show that the perceptual visual quality in scenes with auditory content is higher than that of without auditory content in both scene types. Cohen's D indicates that adding auditory content consistent with the visual semantics of the scene in VR can significantly enhance participants' visual perception quality in VR. We conduct the Pilot User Study 2 to further quantify the maximum imperceptible reduction in foveated rendering quality under various audio conditions. Experimental results in Pilot User Study 2 show that the perceptual visual quality is significantly different with varying auditory factors under each foveated rendering condition. Reducing the eccentricity angle of the foveal region from L1 to L3 within specific loudness and frequency ranges, shows no significant difference in p-value. And reducing the eccentricity angle of the transitional region from C1 to C3 within specific loudness and frequency ranges, shows no significant difference in p-value. Based on the findings that auditory content has significant impacts in the perceived visual quality of foveated rendering, we propose the audiovisual foveated rendering to improve the rendering performance. We first extract the auditory perception loudness feature and the auditory perception frequency feature based on the auditory content in VR. Then, we extract the CSF-based visual loss feature based on the visual content in VR. After that, we jointly model the HVS's visual perceptual ability based on auditory and visual features in foveated rendering. Based on the guidance of AVPM, we propose the foveated rendering cost optimization algorithm to construct the required shading rate map in VRS pipeline. Finally, we generate the foveated rendering result in VRS pipeline with the guidance of the required shading rate map. We compare the foveated rendering results among AVFR, the SOTA VR foveated rendering FR, and SOTA VR foveated rendering FR' with the same frame rate as AVFR. Experimental results show that the perceived visual quality of AVFR is comparable to FR, while AVFR achieves up to a 1.4 times speedup. And our method achieves significantly higher perceived visual quality than FR prime.